Hey guys, welcome back. Today is day 38 and we are going to be talking about systems of inequalities, and this is day 2. So let's start on the notes. 39A. You should have done 38B, the homework, and I hope you compared your answers to those that are provided in the answer key on Schoology. So 39A, we start out and we just do a little bit of a review about what we did on day 38. So we learned how to graph systems of inequalities and how we do that. The first example we have x is greater than 2. So x is greater than, you're going to think of hoy bucks, and in this case it's going to be a bucks. All right, so you've got a vertical line. X is at 2 and it's going to be greater than 2. So I look at my inequality symbol. Notice it's just greater than, so I know it's going to be a dashed line. Okay, so that's a dashed vertical line. All right, we can test the point 0, 0 to see which side to shade on, or you can just think of it as x is greater than, so think of the number line, it would be to the right, all the values, okay? Or if you tested 0, 0, it would be 0 is greater than 2, which is false, which means you would shade on this side of the line, okay? But this would be x is greater than 2, okay? All right, so then the next inequality is y is less than or equal to negative 3. So in this case, we're going to think of hoy, because we have the y there, and that means it's a horizontal line. We go to negative 3, and in this case, it's less than or equal to, so we're going to make a solid line. Okay, treat the y-axis like a number line, and anything less than or equal to would be below the line, so that when you shade it, it would look like this. Okay, so the area right in here where we have the double shading, this would be the solution set. Okay, so all of the ordered pairs in that area would be a solution to the inequality. Now keep in mind that if the ordered pairs happen to be along the solid line, the boundary line, that would be included in the set. But if it's on a dashed line, it would not be included on the set. Okay? All right, so looking at number 2, we start out, and before I graph, I always put it into slope-intercept form. Okay, from here it's easy to figure out your slope, which is -1, and your y-intercept, which is -2. Makes it easier to graph. You start at your y-intercept of -2, and your slope is -1. Okay, so by now you should be pretty good at graphing lines. All right, so I do some dots. I look at my inequality symbol. I notice it's just less than, so in this case it's just going to be a dashed line. Okay, and then I'm going to decide which side to shade. So I pick a point. Most of the time I pick 0, 0, just because it's a little bit easier. I plug it in, and when I plug in the value 0, 0 for my x and my y, I get 0 is less than -2. Well, that's a false statement because 0 is actually greater than -2. So therefore, I want to shade not the side that has 0, 0, but the actual other side. So I shade that other side, and it looks like this. Okay, now looking at the next inequality that we have, I'm going to put it into slope-intercept form. So for purposes of space, I'm going to do that up here. I get -y is less than or equal to -5x, okay, minus 3. All right, now I'm going to be careful here because I'm going to divide both sides by -1. Now remember, with an inequality, you need to flip the inequality symbol, okay, when you divide by a negative. Okay, so I flip it to greater than or equal to. That's a positive 5x plus 3. From there, I can identify my slope is 5, my y-intercept is 3. Okay, so it's a little bit easier to graph. I start at my y-intercept of 3, and my slope is 5, so I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. Okay, my inequality symbol is greater than or equal to, so that means I'm going to make a straight line, okay, solid line. Whoops, that's kind of funny looking. Sorry, it's not that straight. Okay, should look like this. Okay, there we go. Okay, so there's my line. Keep in mind I'm doing this on a little tilt. Okay, all right, so I want to test the point 0, 0. So I plug in 0, and I get 0 is greater than or equal to 3. That's also false. So I'm not going to shade the line, the side of the line where the 0, 0 is. Instead, I'm going to shade the other side of the line. Okay, which would be over here. All right, so then the double shaded area right in through here would be the solution set. Okay, again, the ordered pair can be anywhere in that area. Okay, here's a bunch of ordered pairs. All right, any of them, infinite number, as long as it's not on a dashed line, but the ordered pairs could be on the solid line. That's fine. And keep in mind, the intersection between the dashed line and the solid line is not part of the solution set because part of that ordered pair is on the dashed line. As long as even part of it is the dashed line, you're not going to include it in the solution set. All right, let's look at our next example for number 3. Now we're just going to look at it and see if the point 2, negative 2 satisfies the system of inequalities. So you can actually look at this problem 2 different ways. You can either just plug the 2 values in, your x and your y, and remember it has to be true for both. So when we plug it in, we've got 5 times 2 plus our y is a negative 2. Is that greater than or equal to 3? 10 minus 2 is greater than or equal to 3. We've got 8 is greater than or equal to 3. So that's true. But it's got to be true for both inequalities. So the second one is y is greater than negative 2. Well, our y value is negative 2. Is that greater than negative 2? Actually, that's a false. Okay, had it been greater than or equal to, it would be true, but because it just says greater than, that's false. If you have a true and a false, this is a no. Remember, it's got to be true for both of them to be a solution to the system of inequalities. Okay? All right, so now this is where it gets a little tricky. Okay, now we're going backwards. All right, and you got to keep yourself organized. Now we have the solution, and we want to write the system of inequalities. Okay, so I'm going to start out and I identify my lines. There's my first line. Okay, so my first line, if I look at it, it's a horizontal line. So I'm going to think of HOI. Okay, which means it starts with Y, okay? Now, in order for that shaded area to be the overlapping shaded region, that means that the line that I'm working with actually had shaded everything here, okay? So that means it's everything below the line, or in this case, it's less than 3, okay? So notice it's actually a dashed line, so it's just Y is less than 3. Okay, so that's the first inequality. Now I'll look at the second inequality. All right, let's look at this line right here. I like to first identify my y-intercept. Okay, my y-intercept is right here. It's where it crosses the y-axis, and my y-intercept is 1. My slope, if I go up 1 and to the left 1, is going to be a negative 1. Okay, so from here, I set up my inequality. I've got think of slope-intercept form. So I've got a negative x plus 1 because it's negative 1x plus 1. But I've got to figure out what inequality symbol goes in here. Okay? All right, so I look at that line, all right, and in order for this to be the double shaded area, that means I actually shade this area here. Okay? That means that the point 0, 0 is actually true. Okay, so if I put in 0, 0, all right, I would have 0, and then I would have a 1. Okay, what's going to go in here is 0 is less than 1. Okay, but because it's a solid line, it's actually going to be less than or equal to. Okay, so that's how we get our 2 inequalities. So the answer would be y is less than 3, and y is less than or equal to negative x plus 1. Okay, so that's how we write the system of inequalities represented by the graph. Okay, all right, so let's look at number 5. We're going to do a few more. Okay, the key to this is really keeping yourself organized. So my first line that I'm going to look at, all right, I like to first identify my slope and my y-intercept. I usually start with the y-intercept. Okay, there it is, it's 2. Okay, and now my slope in this case, I'm going to go down 1 and over, down 1 and over. So I'm thinking, all right, negative slope, it's a negative 1. Okay, all right, so I put it into the beginning of that slope intercept form. I've got y and negative x plus 2. Okay, so now I need to know what goes in here. All right, well, you might look at it and notice first that it is a solid line. So whatever it is going to have an equal sign underneath it. Okay, now for this particular example, when we shaded, we actually shaded this area, okay, in order to get that double shaded area. That means that the ordered pair 0, 0 is false in this case. So if we put in 0 and 0, we would get 0 and 0 plus 2, and we want it to be a false situation. Well, we won't know that 0 is less than 2. So to make it false, we want to go greater than. Okay, so there's our inequality. Y is greater than or equal to negative x plus 2. There's one of them. All right, let's look at number 2. All right, so number 2, here's our line. Okay, I'm going to identify my slope and my y-intercept. Again, I start at my y-intercept first. I've got a negative 1. Okay, I'm going to note where the line crosses, which is right up here. So I'm going to go up 1, 2, 3, 4, and over 1. So in this case, my slope is going to be a negative 4. Okay. All right, so let's put it into slope-intercept form. We've got y, and then we've got negative 4x minus 1. Okay, we need to figure out what goes there. All right, so with that particular line, all right, in order for that to be the shaded region, okay, if we took this line, we would make this all shaded. That means 0, 0 is actually true. Okay, so for 0, 0 to be true, we would have a 0 and a negative 1. We want that to be true. Well, we know that 0 is greater than. And in this case, it's a straight line, so it's greater than or equal to. So our two inequalities would be y is greater than or equal to negative x plus 2, and y is greater than or equal to negative 4x minus 1. Okay, and with these, I highly recommend putting both of them into Desmos and checking your work. If you put both of those inequalities in, you'll see that the overlapping shaded region will be up here in the corner. Okay, so it definitely is helpful to check your work with this. All right, let's try a couple more. All right, so number 6, I'm going to start out with the first. Okay, the very first one, I'm going to start with my slope and my y-intercept. My y-intercept is a positive 2. Okay, my slope in this case, I'm going to go, it's kind of, let's see, find a place where it actually crosses. There's one. So I'm going to go 1, 2, 3, 4, 1, 2, 3. So my slope is going to be 4/3. Okay, so when I have 4/3, all right, I'm going to start to put it in slope-intercept form. It's y, and I've got 4/3 x plus 2. Okay, so for that to be the shaded region, that means that I'm shading below the line like this. Okay, that means that 0, 0 would be true. So I'm going to try to figure out what goes in here. I put in 0, 0, and I've got 0 and 2, and I want that to be true. Okay, well in this case 0 is less than 2, but it's a solid line, so it's actually less than or equal to. Okay, so there's our first inequality. All right, and our second inequality, okay, let's look at the line here. Okay, we've got our slope and our y-intercept. The y-intercept is at negative 1 right here. And our slope, we're going to rise 1, 1, 2, 3. Okay, it looks like our slope is 1/3. Okay, so we put our inequality in. We've got y, and we've got 1/3 x minus 1. Okay, so with that particular line, it looks like in order for that to be the shaded region, we're actually shading above. Okay, so when we do that, 0, 0 is actually true. So we've got 0 and a negative 1, and we want that to be true. So in this case, 0 is greater than negative 1. But we look at our line, and again, it's a solid line, so it's going to be greater than or equal to. All right, so our inequalities would be here and here. Okay, there's our two inequalities. All right, so looking at number 7, and this would probably be a good idea to actually pause the video right here and try it yourself, okay, and then let's see how you do. Okay, I'll go ahead, identify my y-intercept. Okay, so for this one right here, my y-intercept is going to be at a negative 3. We'll do line 1. All right, our y-intercept is at negative 3, and our slope is going to be, let's see, we're going to go up 2 and over 1. So it looks like our slope is negative 2. Okay, so we put it in slope-intercept form. We've got negative 2x minus 3. It's a dashed line, so we're not going to worry about that equals. Okay, but in order to get this double shaded area with this line, it looks like we shaded this side, which means 0, 0 would be false. Okay, so let's put in a 0 and our negative 3, and we want it to be false. Well, we know that 0 is greater than negative 3 to be true, so let's make it less than negative 3 to be false. Okay, so there's our first inequality. Y is less than negative 2x minus 3. All right, now the second inequality that we do, all right, our y-intercept is going to be positive 1, and our slope here is going to be, let's see, go down 2 and over, so it looks like it's going to be a positive 2. Okay, all right, we put it in slope-intercept form. We've got y and we've got 2x plus 1. Okay, it's a solid line, so we know we're going to have that little equal sign there. Now for the double shaded area with graph number 2, all right, we would have had to shade this side to make that the double shaded area, which means 0, 0 is false. Okay, so if I put in 0, 0, I want it to be false. Here 2 times 0 is 0, and we got 1. We want that to be false. So we do know that 0 is less than 1 to make it true, so let's make it greater than 1 to be false. Okay, so in this case, there's our second inequality. Okay, there's our first one, and there's our second one. Okay, so that was definitely trickier. Okay, all right, so let's see what happens with number 8. It says determine which region would be shaded given the following system of inequalities. Okay, so in order to do that, you could do this one a couple of different ways. Okay, so you can put them both into slope-intercept form, okay, and just try to figure out the graph, all right? Or you could actually put them both into Desmos and see the shaded area, okay? But I'm going to go ahead and make sure that we can take the first one and put it into slope-intercept form. Okay, negative 5x minus 4, and then I divide by negative 2. Now remember, I'm dividing both sides by a negative here, so I've got to flip my inequality sign. Okay, so that lines up with this line right here. Okay, looks like that's the line right here, number 1. All right, so in order to see which side to shade, I'm going to put in the point 0, 0, and we get 0 is greater than or equal to 2. Okay, so we're testing this point. In that case, that's a false statement. It's not greater than 2. So we're actually going to shade the other side of the line here. So that side's going to be shaded like that. Okay, now I'm going to work with the second equation. All right, so I'm going to bring the x to the other side, and I get 2y is greater than or equal to x minus 4. And then I divide both sides by 2. Y is greater than or equal to 1/2 x minus 2. Okay, so that lines up with this. All right, looks good. All right, so I'm going to test the point 0, 0. And when I do, I get 0 is greater than or equal to negative 2. That's a true statement. Okay, so that means I'm going to shade everything above that line. Okay, and when I do that, the double shaded region is region 2. Okay, so there it is. The answer is region 2. Okay, all right. Moving on, for the rest of them here, we've got, we skipped some, so we're going to go right to 14. Okay, we're going to write a system of linear inequalities to model each situation, but we're not going to solve them. Okay, if you wanted to solve them, you could put them into Desmos and see the solution area. But let's get some practice with modeling these word problems. Okay, so just like when we did systems of equations, the key to the word problems is the let statement. Okay, so defining your variables. Bob has at least $5,000 in savings, and his savings balance is more than 3 times greater than his checking balance. Okay, let's let X be equal to the savings, and let's let Y be equal to the checking. Okay, so with that, we have 2 variables. We know we're going to need 2 inequalities. Bob has at least $5,000 in savings. That means his savings is going to be greater than or equal to the $5,000. Okay, it could be 5,000, but it could also be 10,000 or 20,000 or 5,001. Okay, now the second part says his savings balance is more than 3 times greater than his checking balance. Okay, so his savings is X, and it's more than 3 times. So more than would just be greater than, okay? And then our checking would be 3y. So there it is. Okay, we don't have to do anything else with it but come up with the 2 inequalities. All right, looking at 15, Jonah is going to the store to buy candles. Small candles cost $3.50 and large candles cost $5. He needs to buy at least 20 candles and he can spend no more than $80. Okay, So again, our let statement, let's let X be the small candles, and let's let Y be the large candles. We need our two inequalities. He needs to buy at least 20 candles. So if you take your small candles and your large, and you want to be at least 20, that means it's going to be greater than or equal to 20. Okay, at least would be greater than or equal to. Now the money one, okay, small candles are $3.50. Okay, let's see if my pen will write. There it is. So 3.5x, and large candles are $5. And he can spend no more than $80. So that means he has to spend $80 or less. So it's going to be less than or equal to 80. And there's our inequalities. All right, John is doing a fundraiser for school. He needs to sell at least $200 worth of items. Shirts cost $10 each and hats cost $8 each. He must sell more than 12 hats. So let's start with our let statement. So let's let X be equal to the shirts and Y be equal to hats. Okay, so he needs to sell at least $200 worth of items. And let's see, so $200 worth of items. If shirts are $10 each, it would be 10x, and hats are $8 each and 8y. And it has to be at least 200, so that means it's going to be greater than or equal to 200. Okay, because it could be 300 or 400 or just 200. Okay, he must sell more than 12 hats. So hats have to be greater than 12. Okay, there's our inequality. All right, let's interpret some graphs. Okay, McWani wants to download songs and lectures on his smartphone. He plans to download 30 songs and lectures. That's condition A. All right, so here's our lectures. Our y-axis would be our lectures, and our songs would be on our x-axis. Okay. The graph represents the constraints on the number of songs and lectures that McWani downloads. Okay, so if we look at the constraints, the area, it says what's the greatest number of lectures he can download while meeting both constraints? Well, both constraints are right in here. Here's our solution set. Okay, the question's asking, okay, what is the greatest number of lectures? So we simply look at that area and we go to the highest point possible for lectures. All right, and then we go over here and we can see it's 15. So this would be 15 lectures. That's the greatest number of lectures. All right, the greatest number of songs, we would go down here and look, it would be 60. Okay, but he wouldn't have any room for lectures. All right, make sure you look at and interpret the graph. All right, number 18, what is the solution to this system of equation? Here's our one that has no solution. Remember, there's no overlapping area, therefore there's no solution. Okay, that's how you're going to end up with a no solution. All right, so that's it for today. Test will be actually next class, so make sure that you finish the study guide, which is out there. It's 39B. Bye.